So good morning everyone and welcome to this lecture. This is lecture number 2 and we are dealing with errors and measurement. In the previous lecture, uh, we had gone through the first part of significant figures. Do we remember this?
Yes, sir.
So let us see what we are going to do in this one. We are going to see what are errors, what are the different types of errors. You have an idea about different types of errors?
Yes, sir. Random error.
Propagation of errors, how do errors move ahead, and we will solve some practice problems as well as we will take some previous year questions. What did we do in the last class? In the last class, we had seen what? We had seen your significant figures, yes or no?
Yes, sir.
We had seen what do you mean by significant figures. We had seen some questions based on this. We had solved some previous year questions and we had seen some general rules of rounding off and all that. Very rarely a question will come only on significant figures. If it comes, it might have significant figures, it might have errors built into it. Anyways, let us move on. And this is a more likely scenario of you having a question. Now, whenever we talk about measurement, we are measuring something. When we are measuring something with measuring instruments, there is always a difference between the actual value, the length, breadth, height, whatever you are measuring, area, volume, and the length, breadth, height that we have measured. The actual value or the real value may be called as the true value. Now, remember and don't get confused. When I say true value, this true value means when I'm measuring something and if I want to find out precisely, accurately how much is the measurement, I have to measure it more than one time. Do we understand this?
Yes, sir.
If I measure it more than one time, many times, I may get different readings. If I take the mean, the arithmetic mean or average of all these readings, then the average of all those readings would be very close to the actual reading, the actual value, and that is taken as the true value of the quantity. So true value of the quantity is the arithmetic mean of all the observations that you have done. For example, if you are making a number of observations A1, A2, A3 up till let us say AN, you are making n number of observations A1, A2, A3 up till AN is your readings or values that you get in these different observations. The true value, what will be the true value? True value of that thing would be taken as A1 plus A2 plus A3 up till AN divided by N, or I can write it as summation of AI from I is equal to 1 to N divided by N. You can also call it AM, average value. Remember that sign for average value that I had told you, yes or no?
Yes, sir.
So this average value, this average of all those readings that you have found out, that you have recorded, is known as your average value or your true value. Do we understand this, everyone?
Yes, sir.
I'll give you a minute to note this down. Now we've understood what is the true value. This is a simple problem that we can do on this. In a series of successive experiments, you find the length of the rod, different values are given. Can you tell me what is the true value? What is the true value of, or what would be the length of this rod? The true value, the length of this rod. The options are given. Which option is correct? Which option is correct? And the answer is,
Sir, I didn't find the answer. I'm getting 10.
oh yes, I think the options are given wrong. The answer would be 10. How did you get 10? You just have to find out, the average or the mean of these quantities. How will you find out the average or the mean? You have to add this 10.4 plus 10.6 plus 9.4 plus 9.6 plus 10.2 plus 9.8, and you have to divide it by the number of readings, and I guess the value that you are going to get is 10 meters. Yes or no? Do we understand this?
Yes.
So, to get the true value or the real value, you have to take the mean. Do you understand this?
Yes, sir.
Okay. The next thing that you have to understand is what are errors. Well, as you saw in the previous case, when we made different measurements, we took different readings of the same rod, we got different values. The true value is taken as the average of those, so we take the average, that we call as the true value or the real value. The difference between the true value and the measured value is known as your error. The difference between the true value and the measured value is known as your error. So if I take the previous example, the true value, the mean value was coming as how much? It was coming as 10. Yes or no?
Yes, sir.
So if I go back to the previous question, the mean value, as you can see, is coming. Oops. The mean value, as you can see, is 10, and in different cases, you got different values. In first case, you got the value as 10.4. So there was an error. How much was the error?
0.4.
It was for 0.4 meters. It was more. In the second case, it was 0.6. In the third case, it was 0.6, but it was less than the original value. In the fourth case, it was 0.4, but it was also less than the value. Do you understand this?
Yes, sir.
This difference between the true value and the measured value is known as your error. Do we understand this?
Yes, sir.
Everyone understands this? Shall we move ahead?
Yes, sir.
Then what are the types of error? What are the different types of error that you can have? And I think you know about this. The first type of error, we don't have to go in much detail. You just have to understand the meaning. The first type of error is the instrument error. What is instrument error? A zero error is an instrument error. Uh, if the instrument is not properly marked, it is broken. Something wrong with the instrument. The markings are not proper. The temperature of the temperature has changed. Remember, when the temperature changes, the marking space between the marking changes.
Yes, sir.
The instrument can have an error. There can be an error in the instrument only. Because of those, there will be an error in the readings that you record, and that errors are known as instrumental error. Do you understand this?
Yes, sir.
The second one are environmental errors. Similar, if the temperature increases, the marking space increases or decreases. Those type of errors which occur because of environment. If it is very cold or if it is very hot, your readings may vary. Yes or no? The time
Yes.
period of the pendulum also varies. These type of errors are known as environmental error, which are produced by the environment. Do we understand this?
Yes, sir.
Observational error, well, depending on an individual, some might feel that the length of the rod is coming as 10.4. The other person might say no, it is 10.3. I can. The third marking is coinciding. Remember vernier caliper.
Yes,
Some
sir.
might feel that third marking is coinciding, others might feel that the fourth marking is coinciding. Therefore, there could be an error in the observation. Some might be seeing it from this angle, some might be seeing from this angle, some might be seeing from this angle. Different observation points, observational error. Then there are random errors. They can happen anytime. I might be noting the exact value, but I might be writing something else. Any error can be called as random error. Do we understand this?
Yes, sir.
These are the four different types of errors. If we move ahead, let us now talk about how do we measure these errors. So the first type of thing here that you must understand is known as the absolute error. What is absolute error? The absolute error is the difference between the true value and the measured value. So when we talked about error, we said key error is the difference between the measured and the true value. That is actually known as the absolute error. The absolute error is the magnitude of difference. Remember, error is, when we talk about errors, even if we are getting the error as negative error, we always think it of, whenever we are talking about errors, remember, errors never get subtracted, error always gets added. Do we understand this?
Yes, sir.
Now, so if the error is minus zero point 0.6 or if the error is plus zero point 0.6, minus and plus in that error will only tell us whether we are getting more value or whether we are getting less value. Do we understand this?
Yes, sir.
The actual value of the product, the actual length of a rod may be 10 meter. I might be getting 9.4. I might be getting 10.6. In both cases, the error is 0.6. In first case, I am getting less value. In second case, I am getting more value. So the difference between the true value and the measured value is known as your absolute error. It is denoted by the letter delta A. If I say my measurements are A1, A2, A3, and so on, let me have M number of measurements. Let me have n number of measurements. I should take the same values. I have n number of measurements. So let me not take it as m. Let me take it as n. I have n number of measurements. So this would be, these are my observations. From this observation, I can find out the mean value or the true value. What will be the mean value or the true value? Everyone knows it? Or the average value? It will be summation of
Summation of
AI
AI
divided
I
by
equals to 1
n.
to.
Yes or no?
Yes, sir.
Now, I have made n number of observations, so I will have n number of absolute errors. The absolute errors, let me draw a line here. The absolute error in the first measurement, I will call it as delta A1. What will be the absolute error in the first measurement? I will write it as A1 minus AM, and I might put a modulus sign here so that I understand that error is whether it is positive or negative. Positive or negative only is going to tell me whether I'm going getting less or more value. Do we understand this?
Yes, sir.
Similarly, if I have delta A2, what will be delta A2? The absolute error in the measurement of the second reading, that will be equal to mod of A2 minus AM or A average. Do we understand this? We understand this? Similarly, I can have the error in the nth measurement AN minus AM, and I can take the mod of these things. Do we understand this? Do we understand this?
Yes, sir.
Have you noted this down?
Yes.
So that is how you can find the absolute error. This is what it is given in this one. Oops, I always make this mistake. So absolute error in the first measurement will be this one. You can put it in mod if you want to. The error in the nth measurement would be like this. Do we understand this?
Yes, sir.
Now we can solve the same question, the question that we did, and we can find out the absolute error in all the 6 cases. What will be the absolute error in the first case? Tell me.
It is 10.4 minus 10.
10.4 minus 10, so I can write it as
0.4.
0.4. What will be the absolute error in the second case?
It is 6, sir. 0.6.
0.6. I can write it as plus just to understand that I am getting more. Yes or no?
Yes, sir.
In the third case, what is the error?
It is 0.6 minus.
0.6 minus only indicates that I will get less value. Do we understand this?
Yes, sir.
In the fourth case,
It is 0.4, sir.
0.4 minus will only indicate that I got less value. In the fifth case,
0.2.
minus, no, plus, it is only plus. In the sixth case,
0.2.
in this case, I will get less values. Do we understand this?
Yes, sir.
Now, the next question arises, what is the next thing that we are going to understand? And it comes automatically. I have got different values here, different absolute error. The next heading is mean of absolute error, delta AM. Do I need to elaborate what will be this mean equal to? It is the mean of all these absolute errors. Do we understand this?
Yes, sir.
So I can write delta AM mean will be equal to delta A1 plus delta A2 up till delta AN divided by n, or I can write it as summation of delta I from 1 to n divided by n. Do we understand this?
Yes, sir.
This would be known as mean absolute error or mean of absolute errors. I'll give you a minute to note this down.
Done.
Then let us move ahead and do the same question. But in this case, we will find the mean absolute error. What will be the mean absolute error?
0.5.
So how did you get the mean absolute error? To get the mean absolute error, delta AM, you have to find the summation of delta AI and divide it by n. So it will be, remember, everything should be taken as positive. 0.4 plus 0.6 plus 0.6 plus 0.4 plus 0.2 plus 0.2 divided by 6. How much are you getting?
0.4, sir.
You said 0.5, now it has become 0.4. Okay, this is the mean absolute error. Do we understand this?
Yes, sir.
Anyone understands this? Shall we move ahead?
Yes, sir.
The next one is relative error. What will you mean by relative error? The relative error is the ratio of mean to the true value. The mean absolute error divided by the true value or the mean value is known as relative error. So I can write delta AR will be equal to delta AM divided by AM. This tells us what is the ratio of the error, the mean of the error that you got divided by the true value or the mean value. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Have you noted it down?
Yes, sir.
Then in the same question, can we find out what is the relative error? So what will be the relative error here?
0.04.
Delta AR will be delta AM divided by AM. 0.4 divided by 10, 0.04. Do we understand this?
Yes, sir.
Anyone has noted this down?
Yes, sir.
The next thing is percentage error, and this is nothing but the same relative error expressed in percentage. So how can I write this? To write this, I will just write delta A in percentage will be equal to delta AM divided by AM, and it has to be converted into percentage into 100%. Do we understand this?
Yes, sir.
Have you noted this down?
Yes, sir.
Then in this case, our original case, what will be the percentage error?
4, sir.
Percentage error will be delta AM divided by AM multiplied by 100%, 0.04 multiplied by 100, and you will get your answer as 4%. Do you understand this?
Yes, sir.
Okay, now have you noted this down?
Yes, sir.
This is the next question, and I'll give you 2 minutes to solve this. The side of an object is measured by means of a vernier caliper is 3.52. The least count of the vernier caliper is 0.01 centimeter. Estimate the percentage error in measurement, and I'll give you 2 minutes to give this. So how are we supposed to do this? Well, the measurement of the side is coming as 3.52 centimeters, and the least count of the instrument, the most precise measurement that the instrument can give us, that is known as the least count. Do we remember what is least count?
Yes, sir.
That is 0.01 centimeter. Estimate the percentage error. So how will you find out the percentage error in this case? Remember, the percentage error in this case will be given by 0.01, which is the least count. That is the error that you will have. That is the maximum error that you can have. Do you understand this?
Yes, sir.
Because that is the level up to which you can calculate this. So the value, if you are getting from 1 year caliper, is 3.52. It can only vary from 3.51 to 3.53, because that is how precise the calculation for that thing is. Do we understand this?
Yes, sir.
0.01 divided by 3.52 multiplied by
100.
100%. That would be your percentage error in the calculation. And I think the answer is option D. Remember this. Keep this question in your head. Have you noted this down?
Yes, sir.
As you can see in the next slide, the option is D. If a question comes like this, remember how it has to be solved. Do we get this?
Yes, sir.
Shall we move ahead?
Yes, sir.
Then this is the next question. The side of a cube. The side of a cube is given as 20.44 plus or minus 0.02. You understand this plus or minus? That is the zero error. That is not the zero error. That is a sort of error that you can have. Find the percentage error in the measurement. I'll give you 2 minutes to give me the answer for this one. So how are we going to get the answer for this one? It is pretty simple. The error, to find out the percentage error, you will have to divide. How much is the error? Error is 0.02 divided by the true value is 20.44, and you have to simply multiply it by 100%. And when you do this, you will get the answer as 0.0098%, and that is the answer that we are looking at. That is the answer. You will have to calculate it, and that is how you get the answer. Do you understand this?
Yes, sir.
Shall we move on to the next question?
Yes, sir.
This is the next question. This is how questions are framed. The time period of oscillation of a simple pendulum in an experiment is given by these values. Find all these things. I'll give you 2 minutes to give me the answer. So how are we supposed to do this? As you can see, we just need to calculate it. Yes or no?
Yes, sir.
The mean time period or the true time period will be the average value. Yes or no? So it will be 2.63 plus 2.56 plus 2.42 and up till 2.8 and divided by the number of observations. How many observations are there? 5 observations. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
You can find out the mean value. Can you tell me what is the answer you are getting?
2.62, sir.
2.62 is the answer. Then you can find out absolute error in different cases. In the first case, the absolute error will be 0.01. Yes or
0.01.
no? In the second case, the absolute error will be 0.06 and so on. Yes or no?
Yes, sir.
Then you can find out the mean. I hope you can do this simple calculation. What is the mean of all these errors?
0.108.
0.108. 0.108. Sure.
Yes, sir.
0.108. Okay, I'll take your words. 0.108. Then you can find out the relative error, and then you can find out the percentage error. Yes or no? No, yes.
Yes, sir.
Shall we move ahead?
Yes, sir.
This is the next question. In an experiment, value of refractive index of glass is this. You will be able to find out the question. Shall we move ahead?
Yes, sir.
Okay. Then the next one is combination of errors. What do you mean by combination of errors? When you have errors in different measurements. Suppose, for example, this is a block and you want to measure the length, the breadth, and the depth, and then you probably want to find out its volume. You have errors in measurement of length, you have errors in measurement of breadth, you have errors in measurement of depth, and then you find out the volume. So there would be error in the measurement of volume as well. Yes or no?
Yes, sir.
That is known as your combination of errors. Then how do you find out the errors in combination? The first thing is error in addition. If a quantity is the addition of two numbers a and b, the error in the combination, the error in the addition will be plus or minus the error in a plus the error in b. Remember, errors are always added, errors are never subtracted. Do we understand this?
Yes, sir.
To find out the relative error, you find out the total error and divide it by the true value. Do we understand this?
Yes,
To
sir.
find out the percentage error, you just multiply relative error by 100%. We all understand this? Yes or no?
Yes, sir.
Shall we move ahead?
Yes, sir.
The second one will be error in subtraction. Do we understand error in subtraction? First, you have to find out the total error. Remember, in total error, errors are always added, errors are never subtracted. Do we understand this?
Yes, sir.
Then you find out the relative error, total error divided by the value. Value is a minus b, but error is not. Error in a, error of a minus a, error of b. Do we understand this?
Yes, sir.
Then to find out the percentage error, we multiply the relative error by 100%. We get this?
Yes, sir.
Noted this down.
Yes, sir.
Then we have errors in multiplication. When we have multiplication, x is the multiplication of a and b. The relative error in the value a, delta x by x is the original value, true value, delta a by a plus delta b by b. We understand this?
Yes, sir.
The percentage error will be multiplied by 100%. We understand this?
Yes, sir.
If it is division also, the same thing prevails. Remember, it does not get subtracted, it always get added. Do we remember this? Do we understand this?
Yes, sir.
To find out the percentage, you multiply it by 100, yes or no?
Yes, sir.
In general, if you have powers, this is how the formula looks like. If x is a power a raised to the power p, b raised to the power q, c raised to the power r, then the formula will look like this. To find out the percentage, you just multiply it by 100%. Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Then we'll solve one question. This one, I'll give you 2 minutes to give me the answer. So, how are we supposed to solve this? Percentage error in L by T square. The percentage error in L by T square will be percentage error of delta L by L plus 2 times delta T by T. Yes or no?
Yes, sir.
In percentage. So this will be 3 plus 2 multiplied by 2%. So the answer would be 7%. Do we understand this, everyone?
Yes, sir.
Option would be C. We get this?
Yes, sir.
We'll solve one more on this. Heat generated in a circuit is given by this formula. Can you tell me the percentage error? 1 minute. So what will be the percentage error in the measurement of heat?
It is 6, sir.
So I is squared, R is multiplied. I mean, R is just having power of 1, T is having the power of 2. So the percentage error in the calculation of heat will be 2 times percentage error of current plus the percentage error in resistance plus the percentage error in time. So the answer would be 6%. Option B, yes or no?
Yes, sir.
Next one. Give you 2 minutes to get me the answer for this one. So the answer would be The maximum error in the measurement of force and length. What is the maximum error in the pressure? So you must know what is pressure. Pressure is force divided by area. So this is force divided by length square. So the percentage error in the calculation of pressure will be percentage error in force plus 2 times percentage error in length. Yes or no?
Yes, sir.
So it will be 4 plus 2 multiplied by 2, and the answer that you will end up will be 8%. We get this, yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
So the answer would be D. We'll move on. I think the time is there to solve one more question. So this is the next question that you will have. The length of a cylinder with a meter rod having least count of 0.1. Diameter is measured with vernier caliper. The least count is 0.01 centimeter. Length is 5 centimeter. Radius is 2 centimeter. What is the percentage error in the calculation of volume? How will you solve this question?
Sir, I will first find relative percentage error of length and radius, and then I will go for the volume.
Right. So if you remember, volume is pi r square L. Yes or no?
Yes,
So
sir.
the percentage error in volume will be 2 times percentage error in radius plus percentage error in length. Yes or no?
Yes,
So this will be 2 multiplied by diameter is measured as least count is 0.01 centimeter. So the percentage error will be 0.01 divided by 2. Yes or no?
yes, sir.
Plus the percentage error is 0.5 divided 0.1 divided by 5. Yes or no?
Yes, sir.
From here you will get up the answer, and I think the answer that is given is C, 2%. We get this?
Yes, sir.
Anyone understands this?
Yes, sir.
Well, then that brings us to an end of this class. What we have done in today's class. In today's class, we had seen what they mean by errors, and we had seen some questions based on errors. Absolute error, measured value minus true value, mean absolute error, the mean of all these, relative error, mean divided by the true value, percentage error, relative error multiplied by 100%. Do we all remember this? Do you all understand this?
Yes, sir.
And we will end up this class here. In the next class, we will move ahead with the next topic. Take care. God bless you all. Bye bye.
Bye, sir.